PHP is a powerful, free, open-source web scripting and programming language. It's widely used in the web development industry as a result of its speed, stability, and cross-platform compatibility. This means that PHP can run on a Linux production server, a Windows development server, and on a Mac testing server. For the purpose of these lessons, you'll need the WAMP or MAMP testing server installed on your system. If you're taking this course as part of the Web Development Masterclass, you might recall that we did this early in the course. In the next lesson, we'll talk more about making the necessary preparations for hosting your PHP scripts. It's important to note that PHP processes scripts on the web server. This is unlike JavaScript, HTML, or CSS that process scripts on the client side or a web browser. Let's take a look at how PHP works through an illustration. Say, for example, we were visiting a web page from our home computer that contained some PHP code. Our request travels through the web to the web server hosting the website and all of its files. In order to process our request, the web server requires various components to execute the PHP script. First, the web server would need Apache installed to intercept the request and retrieve the PHP file from our web server. Apache would then parse the file and determine that certain parts of the page have PHP code that need to be executed. Apache has a PHP plugin built in that can execute the instructions contained within a PHP script. As an example, a common set of instructions include retrieving and inputting data into a database, although the script can be something as simple as a basic calculation. Regardless, Apache returns the script and renders the page as instructed by the PHP code. It then sends the file back through the web to your PC and ultimately to your web browser. Note that in this diagram, we illustrate the database as a MySQL database. This is a popular type of database that is commonly used with PHP. We'll explore MySQL databases and database queries in the next section of this course. If you're currently taking this course as part of the Web Development Masterclass, you might recall that in the beginning of this course, we installed the WAMP or MAMP testing server on our local machine. We did this specifically to be able to test our developed PHP scripts on our computer without having to upload them to a production server. If you have not done so already, launch your WAMP or MAMP server. To do that, double-click on the icon that looks like this. This icon may be on your desktop, but if not, then you can access it directly from the file path listed below or through your Start menu. The server will launch and you will see a small icon appear on your system tray. When the icon turns green, it's an indication that the WAMP server has successfully started up and is running. If you need a refresher on how to configure the WAMP or MAMP server, refer back to our section on setting up your testing server. In order for us to test our scripts, we need to make sure that we store our PHP scripts inside the web root folder contained within the MAMP or WAMP directory. When you install WAMP, the main folder is typically created inside your C drive. So you'll need to open this folder. So I'll go ahead and access it. So here I'm in the C drive, and as you can see, I have the folder WAMP listed here. If you're on a Mac machine, you'll have MAMP. If I double click in there, we can see the www directory. This is a very important folder. All our websites need to be stored in this folder. It's referred to as the web root folder. It's best to organize all your websites inside this folder. So for example, if we have 4 websites, we would create 4 individual folders that would contain the contents of each site. For the purpose of this course, make a folder called PHP Lessons. We'll store all our PHP scripts in this folder so we can test them as we progress through the course. In this lesson, we will create a basic PHP file that outputs some text into our web browser. The first thing we need to do is confirm our WAMP or MAMP server is configured correctly. To do so, simply open your web browser and type localhost in the address bar. You should then see this page displayed. This is the default WAMP page. It provides some important information about the server configuration, including the Apache and PHP version. It also lists some tools that are included in your package. We'll be using these tools in the next section when we work with MySQL database. The page also lists the websites contained in your web root or www folder. Here, we can see the folder we created in the last lesson, PHP Lessons. Remember that this is where all our files will be saved for this section of the course. To make sure your scripts are working correctly, open Notepad++ and type in the code displayed on the screen. We'll discuss the actual code in the next lesson. This file will just output the text "Hello World" in our web browser using the PHP Echo command. When you're finished typing in the code, save the file in your PHP Lessons folder as intro.php. You can actually give it any file name, but the .php extension is very important. PHP files will not work unless the .php extension is included. You'll notice we've embedded the PHP code in HTML, but even so, we still need to specify the PHP extension. We cannot save it as an HTML file. Type in the following into your web address: localhost/phplessons/intro.php, and press enter. You should now see the text "Hello World" displayed in your web browser. PHP code can be placed anywhere inside a document. It can be placed in any HTML tag, including CSS. A PHP script starts with the open PHP tag and must be closed with the closing tag. In this PHP tag, we have an echo statement. This statement will display the content inside the quotes. In this case, "Hello World." A PHP statement must end with a semicolon. We've also embedded an HTML tag, the HR tag, inside the echo statement. This will display a horizontal line after our "Hello World" text. And here it is in our web browser. We can see the text "Hello World" with the horizontal line beneath. We can create comments in PHP that are not read or executed as part of the page in our web browser. The purpose of a comment is to provide information to a programmer analyzing the code. Comments are very important in PHP because scripts can become lengthy and complicated, especially to someone who's trying to understand the functions or arithmetic that you've coded. In this example, we've illustrated 3 different formats for creating comments. The double slash and number sign can be used for single-line comments. We can create multi-line comments using the slash and asterisk combination. And so you can see that none of this is actually displayed in the web browser. It's only for somebody interpreting the code. We can insert comments inside arithmetic to leave out parts of a code line, as shown here. We have the equation x is equal to 10 plus 5 plus 20. As you can see, 5 has been commented out. So the result of this equation will be 30, as seen in our web browser, because we're only adding 10 plus 20. For now, don't worry about variable declaration. We'll be covering that independently in another lesson. PHP is not case sensitive when dealing with classes and functions such as an if statement, else statements, while, and echo statements. In this case, each echo statement would work despite differences in case. So in the first example, we have echo in capitals, and the desired output is text sample 1 with a horizontal line underneath. And we can see that it outputs just fine. Next, we have lowercase echo. And it's the same line that we're outputting. Just change sample 1 to sample 2. And we can see that it outputs fine as well. Lastly, we have echo with the E and C capitalized and H and O lowercase. And the output text sample 3 with the horizontal line underneath is outputted. Note, however, that variable names are case sensitive. In this example, we have a variable named car, which contains the value Volvo. We then have 3 echo statements, each time changing the case of the variable output car. Only the first line will output the variable correctly, because the case does not match in the second and third line. So we can see here in the first line, the variable to be outputted matches the case of the variable itself, and so it outputs correctly, my car is a Volvo. In the second and third example, the case does not match, and for that reason, we receive 2 error messages, undefined variable car, and once again, the same message here. Notice that the case is incorrect. And that's why we get those messages. If you're unable to see error messages, you'll need to do the following. Click on your WAMP or MAMP icon. Go to the PHP menu. Select PHP settings. And make sure there's a check mark next to display errors. If that's not there, then you will not see error messages in your web browser. In this lesson, we'll be discussing PHP variables. You can think of a variable as a container for storing information. Variables can store both numerical and text data. In this document, we have some PHP embedded in the body of our HTML. In PHP, a variable declaration must start with the $sign, followed by the variable name. In this case, we've named the first variable var1. The var1 variable contains the value hello world. We also have 2 other variables declared, x and y. X holds a value of 15 and y holds a value of 20.5. There are some basic rules when naming variables. A variable must start with the $sign followed by the name of the variable. A variable name must start with a letter or the underscore character. A variable name cannot start with a number. A variable name can only contain alphanumeric characters and underscores. Variable names are case sensitive. When working with variables, the Php Echo Statement is often used to output the data. Here, we've outputted the values contained within each one of the variables we declared, and this is done using the echo statement. We can see that we're outputting the value of var1, followed by an HTML break, and then the value of x, break, and then the value of y. Lastly, we'll be outputting a horizontal line. And you can see the output here in our web browser, hello world, the value of x, which is 15, and the value of y, which is 20.5. We can also output a combination of variables and text. So here we've declared a variable named sport containing the value football. Next, we have an echo statement which outputs the words I like, and then the value of the variable sport, which in this case is football. And we can see the result over here. This is the final output, and we also have a horizontal line, which you can see. We can also use another output method to achieve the same result. So here we have the same variable name, sport, and the same value, football. The only difference is in the format of the echo statement. In this next example, we output the value of one variable added to another. In this case, x plus y. That's what we have in our echo statement. X has been assigned the value of 5, and y has been assigned the value of 6. Notice that we don't have to put quotations around numerical values. And when we add the values together in our web browser, we see that 11 is displayed. When programming in PHP, you'll often work with functions. A function is a block of statements that can be used repeatedly in a program. Functions can be used to perform many different types of actions, and PHP has thousands of them built in. We'll be exploring functions later in this course. For now, it's just important to know how to work with variables inside and outside a function. A variable that is declared outside a function is known as a global scope variable. It can only be accessed outside a function. In this example, we've declared the variable x with a value of 5 outside the function test1. This means that it's a global variable. The purpose of this function is to output the value of x, and we have an echo statement here to do that. Since x has been declared outside the function, the output will not work. It'll produce an error as shown here in our web browser. We can see that the error says undefined variable x. So it does not recognize the variable. Now, in contrast to a global scope variable, we also have local scope variables. A local scope variable can only be accessed inside a function. In this example, we have a function named test2. Inside this function, we've declared variable y and assigned a value of 5. If we try to output the value of y inside the function, then we can see in our browser that it does work. So on the right side, we can see this statement here, value of y is 5. And that corresponds to our echo statement, where we're trying to output the value of y. Since y is declared inside the function, it works. This is a local scope variable. But if we try to access the local scope variable outside of the function, so here we have a separate echo statement where we're trying to output the value of y again, but this time outside the function. Well, this is going to result in an error. And you can see on the right-hand side here that it does not output the actual value of y. It gives us an undefined variable error. So that's the difference between global scope and local scope variables. The global keyword can be used to access global variables that are inside a function. In this example, we have two global variables, x and y. X with a value of 30 and y with a value of 20. Inside the function named test1, we've used the global keyword to access the values of variable x and y. To confirm that this worked, we've set variable y equal the sum of x plus y. So we'll go ahead and execute this function by calling function test1, and also by outputting the new value of variable y, which we know should be 50, which is 30 plus 20. So we can see in our web browser that 50 is in fact outputted. So the global keyword has worked for its purpose. It's important to note that PHP stores all global variables in an array variable called globals. An array is a special variable that can store multiple values. We'll be exploring arrays later in this course. The array index holds the name of a variable. So we can rewrite our existing code as follows. So we can see that here we're referencing global variable y, which we're setting to the sum of global variable x plus global area y. And once again, the output should be the exact same, 50. When a statement is executed inside a function, all the variables and corresponding variable values are deleted. In certain situations, we want local variables to retain their value so they can be used elsewhere. To do so, we can use the static keyword when declaring the variable. As shown in this example, we've set up a function named test1. Inside this function, we've declared a static variable x and assigned an initial value of 10. Next, we have an echo statement to output the value of x, followed by the x++ statement, which will increment the value of x by 1 every time the function is executed. As we can see here below, we've executed this function 1, 2, 3, 4 times. Each time it outputs the value of x plus 1, starting with an initial value of 10. So you can see that in our web browser, the initial value is 10, which is also the initial value of our x variable. Since we've used a static keyword, that variable value is stored, and every time the function runs again, it takes that stored value and adds 1 to it. So after the initial 10, we'd have 11, 12, and 13. And that, you can see, is correct. It's in our web browser. With PHP, there are two ways to get output. We can use the echo or print statement. Both these output methods are relatively the same. The main difference is that echo allows multiple parameters in a statement and print does not. We'll come back to this in a moment. Echo also executes statements slightly faster than print. In this first example, we've used an echo statement to output some text contained within the HTML h1 tags. The HTML tags must be contained inside the quotes along with any text. And you can see the output on the right side here. This is the test header in this echo statement. Next, we have another echo statement with some text followed by an HTML break tag. So again, we're embedding some HTML inside our quotes, and you can see the output for that statement here. The third echo statement contains multiple parameters. We can see each parameter enclosed in quotes, followed by a comma. So you can see the first parameter, the second, the third, and the fourth. And they're all connected by commas to form a sentence, as seen in the output over here. So the print function does not allow this method with multiple parameters. And even using the echo statement, this is very rarely used. And lastly, we just have an echo statement with the HR tag, and that just gives us the horizontal line as a separator. We can output variables using echo. So in this example, we've declared 4 variables: text1, text2, x, and y. So text1 and text2 hold text strings, whereas x and y hold numerical values. Text strings, of course, have to be enclosed in quotations, where numerical values do not. In our first echo statement here, we've outputted the variable text1 inside HTML header tags. In our second echo statement, we've outputted the words I like, followed by variable text2 and an HTML break. The third echo statement outputs the sum of variable x and y. And so we can see the results of these 3 statements right over here. This is the first echo statement with the header 2 tags. This is the second echo statement, and the third. The third is the sum of x and y. The next set of examples do the same thing as what we went over above, only this time it's using print instead of echo. And as you can see from the output, as you go through the code and also the output on the right side, the results are identical. The only difference is we've replaced the word echo with print. The statements are the same as well. And so you can go through that and see how there's really not much difference at all. We can store variable data into different types of variables. Each variable data type has its own unique characteristics and can be used for different things. In this lesson, we'll explore the following data types: string, integer, float, array, null, boolean. We'll explore the object data type in the next lesson. In our first example, we've declared a variable x and assigned the value hello world. This is an example of a string variable because the value is a sequence of characters. We can declare a string variable using single or double quotes. Variable x is enclosed in double quotes, and variable y is enclosed in single quotes. The value is identical and the output is also identical. We've used the echo statement to output the value of variable x and the value of variable y. We can see the output is the same. An integer data type is a non-decimal number. There are certain rules for an integer. An integer must have at least one digit. It cannot have a decimal point. It can be either positive or negative. And integers must be specified in one of three formats: decimal, hexadecimal, or octal. In this example, we've declared a variable called num as an integer with a value set to 6,000. Notice that the value is not enclosed in quotes. Integer variables do not require quotes. Next, we've used our var dump statement to output the data type and value. In our web browser, we can see the variable num is an integer with the value 6,000, just like what we specified. The next data type we have is a float, also known as a floating number point. A float is a number that is in exponential form or that contains a decimal point. In this example, we've declared variable num2 and assigned the value 20.565. Since the value contains a decimal, our var dump statement will output the data type as float. And this can be confirmed over here. We can see that num2, the num2 variable, is a float and the value is 20.565. An array variable can store multiple values. In this example, we've declared the variable sports as an array with 4 values assigned: soccer, tennis, baseball, and football. Using our var dump statement, we can output each value in the array. We'll be working a lot more with arrays later in this course, but for now you can see that with var dump, it specifies that the array size is equal to 4. We can see each index number in this array, 0, 1, 2, and 3, and its corresponding value. And the values are what was specified in our array. So if you find that confusing, don't worry, we'll be working a lot more with arrays later on. The PHP null value is a data type that can only have one value, null. The null value type means the variable has no value assigned to it. We can also empty the value of an existing variable by setting the variable value to null. In this example, we have the variable color with the value assigned initially to blue. We can empty this value by setting the variable to null. So you can see that when we use the var dump statement, it outputs the value null because we've converted the value blue for the variable color into a null value. A Boolean variable can only hold 2 values, true or false. Booleans are used primarily in conditional statements such as if statements, else, and else if. We'll be exploring conditional statements later in this course, but as a general rule, the following values would be considered false. A Boolean that is set to false, as shown in this example, variable y is set to false, so the value of this Boolean would be false, as indicated here. And you can see variable x is set to true, so the value of this Boolean is true. The integer 0 would have a false value. The float 0.0 would also be false. An empty string, an array with 0 elements, a null variable, these would all be considered having a false value. With a couple of exceptions, almost any other value would be considered true. An object data type stores data and also information on how to process the data, known as a method. As an example, a car could be considered an object. A car has certain properties, such as make, model, color, weight, and so on. A method would be considered anything that the car can do, such as travel, turn, stop, or slow down. As a rule, an object must be explicitly declared. The first step to creating an object is to create a class. The class is the set of properties or variables that are tied to an object. In this example, we have the class person. Next, we've defined some properties that the person has. The person object has 3 properties: a first name, a last name, and an age. You'll notice in front of each property we have an assignment called public. There are 3 different types of assignments, including public, private, and protected. Next, we've constructed a function that tells our properties what values will be assigned to the variables: first name, last name, and age. In this case, each time a new person is created, is seen here, the first value contained inside the parenthesis after the new person declaration will be the first name. The second value inside the parenthesis will be the last name, and the third will be the age. Each variable here, person 1 and person 2, creates a new person. Each person has their own unique set of information. We have a method inside our class, and a method is a function tied to an object. This method, which we've called hello, will output a sentence with the person's first name, last name, and age. We've called on this function at the end of our script here. We can see the statement echo person 1, hello. We also have echo person 2, hello. In our web browser, we can see the values of the properties first name, last name, and age have been outputted based on the number of new persons we created, which in this case was 2. And that is how an object works. Note that these values would typically be derived from a database. In this lesson, we'll explore some commonly used functions that apply specifically to strings. We can count the number of words in a string using the string word count function. Here, in the string hello world, we know is 2 separate words, so the output would be 2. We can reverse words in a string using the string reverse method. In the string hello world, the output in reverse would be as follows. We can see that here. The PHP string position function searches for specified text within a string. In this example, we're searching for the word world inside the hello world string. The output in our web browser is 6 because the word world starts at the 6th character position inside the string hello world. So we have 1, 2, 3, 4, 5, and 6, and then world begins. The string replace function will replace a word with another specified word. Here, we've instructed the function to replace the word world with the word John. So what would have originally outputted as hello world will now output as hello John, as seen here. A constant is an identifier for a given value. A constant cannot be changed during the script as a variable can. Also, unlike variables, a constant is automatically global across the entire script. When creating a constant, the name must start with a letter or underscore. A constant does not require a $sign before the name. As shown in this example, a constant can be created using the define function. Inside the function, we start with the constant name, followed by the value. We can also specify whether the constant name should be case insensitive. We'll do that in the second example. In this example, the constant name is set to welcome. The value is the text, "Hello, my name is John Smith." The constant name is case sensitive. We can output the constant by creating an echo statement followed by the constant name, welcome. If we were to set the echo statement to lowercase welcome, the output wouldn't work. First, on the right-hand side, we can see here that the output is correct. It's outputted the value, "Hello, my name is John Smith." But what if we were to change from uppercase to lowercase? Now it does not match our constant name. Well, the case doesn't match. And now we get an error because the case doesn't match. So we'll change it back. In the second example, we've set the case insensitive value to true, shown here. This means when we output our constant, in this case, welcome to, it doesn't matter if we use uppercase or lowercase for the constant name. So you can see that the case here doesn't match in the echo statement. And when we refresh, this time it still works. Constants are global and can be used across the entire script. In this example, we've defined the constant with the name car and set the value to Volvo. We've also created a function, myCar, that outputs the value of constant car using an echo statement. When we run the function, we can see that the browser outputs the value Volvo. Operators are used to perform various operations on variables and values. In this lesson, we'll do an overview of several operators. It's important to note that PHP divides operators into the following groups: arithmetic operators, assignment operators, comparison operators, increment and decrement operators, logical operators, string operators, and array operators. Because of the amount of operators that can be found across these groups, we'll go over a few examples in each group. The file used in this lesson is located in your Downloads folder. You can use it for future reference and also go through each operator if you require further information. We'll start with arithmetic operators. The first section in our PHP file provides an example of the different arithmetic operators available, including addition, subtraction, multiplication, division, and modulus. We can see the output of each echo statement in our web browser. So for example, we've set variable x to equal 50 and variable y to equal 20. The first example here, the first echo statement, uses the addition operator to add the value of variable x with y, and the output is 70. The second example subtracts x minus y, and our output is 30. So it's fairly straightforward. Going down the file, the next operator we have here is the assignment operator. An assignment operator is used to set the value of the left operand to the expression on the right. In this equation, we have variable x, and we use a single equal sign to assign the value 20 to x. So if we were to create an echo statement and output the value of x, well, it would be 20. So we've set the right expression, we've set that value to x. And that is known as an assignment operator. It assigns the value over. Comparison operators are used to compare two values, numbers or strings. In the first example, we've set the value of x to 300 and y to 300 with quotes. Okay, so no quotes and quotes. We've used the var dump function to compare x to y using a double equal sign. The double equal sign is going to check if the value on the left is equal to the value on the right. And because 300 is equal to 300, our output is true. The next operator is three equal signs. So the variable of x and y are set to the same values again, 300 and 300 with quotes for y. Three equal signs will check to see if x is identical to y. And we know it's not identical because y has quotes surrounding it. So the output is false in our web browser because they are not identical. You can go through the remainder of the comparison operators to see the result. They're fairly straightforward, and the comments explain what each one does. Increment operators are used to increment or decrement the value of a variable. If we take a look at the second example, we can see that the initial value of x is set to 50. Using the ++ x in this case, so if our variable was named anything else, we'd replace x with the variable name. We can increment the value of this variable by 1. And you can see on the right-hand side, 50 has been incremented by 1 for a result of 51. In the next example, we can see that we've decremented the value of 50. So x is again equal to 50, and using the minus variable operator, we have decremented by 1 from 50 to 49. Logical operators are used to combine conditional statements. So in the first example here, we have two variables, x and y. X is set to 200 and y is set to 300. We then use an AND operator to check if x is equal to 200 and y is equal to 300. We'll be working a lot more with if statements later on in this course, but in a nutshell, we've instructed the script to output the word true if both these conditions are met. And in this case, the conditions are met, so in our web browser, we get an output of true. In the second example, everything is more or less the same. The difference is we use the OR operator. So if x is equal to 200 or y is equal to 90, we'll output the word true. Since one of these conditions are met, x is equal to 200, we get an output of true. And that's how the logical operators work. There's a few others you can go through as well. Next, we have string operators, and these are specifically to be used with strings. The first example here allows us to attach one string variable to another. In this case, our web browser will output hello and world on the same line. It's attached the value of x with y using the period there. And so you can see the output here, hello world, on the same line. Now we have array operators as well. Array operators allow us to compare and manipulate arrays. In the first example, we've created a union of two arrays. So we have array x and array y. Array x has its own set of values, blue and red, and array y has its values, pink and brown. And using the plus sign, we've created a union of the x array and the y array. So we can see in the output that all the colors of both arrays are listed. And you can go through the other array operators as well. Some of these operators we'll be using in different sections of this course. So again, there's a lot here. It's a fairly long script, and it's more for reference purposes, and you can definitely go through it and see what each one does. All the outputs will be in your web browser when you preview the file. In this lesson, we'll be exploring conditional statements. When writing code, we often want an action to occur based on an event or condition. In PHP, we have different types of conditional statements, including if statements, if-else statements, if-else and else-if statements, and switch statements. We'll start with an example of a basic if statement. Here, we have a variable x set to the value of 49. We've created an if statement with one condition. If the value of x is less than 50, we want to output the words condition met. Since 49 is less than 50, we can see in our web browser that the words were outputted. Condition met. Now, what would happen if the condition was not met? Let's say we set x to 51. In this case, 51 is not less than 50. So there's no output in our web browser. There's no output because we have not instructed our script on how to handle this situation. To do so, we can add an else statement. Let's create an else statement that outputs the words condition not met if x is not less than 50. So let's recap what we've done here. If x is less than 50, output condition met. If x is anything else, and there can only be one other thing, that x is greater than 50, output condition not met. So we can see in our web browser that it now outputs condition not met because x is not less than 50. You can change the value of x to test different results. In this lesson,